In grades 3, 4, and 5, we want to help facilitate our students to move from an additive phase of reasoning into multiplicative. They're very used to skip counting and thinking about multiplication as repeated addition. But how do we transfer that into the next phase of reasoning into multiplicative reasoning? Well, here's an example that I'm seeing a lot in the upper elementary classrooms. I'm using an example of a basic fact, but this is happening with some larger numbers as well as students are trying to calculate some multiplication problems. So let's see if this looks familiar to you. A student is asked to solve 8 times 8. And so they're thinking about it as repeated addition. And they end up making a line of all of those eights, drawing a line, putting a plus sign. And then they got to figure out, well, how many is that in all? And they, of course, want to make it a little bit more efficient for their brain. And what I'm seeing them do is to combine two groups at a time. So they're thinking about two eights, two eights, two eights, and they're labeling it as the 16s. I just want to make that, again, visible for you. I love the Cuisenaire rods because the numbers are existing as a group. So it allows the students to see it's this many eights. And we can eventually also use the idea of partial products of, well, how many eights do you know for sure? And being able to do larger chunks than these doubles. But this is what's happening is they're grouping two of them together. They know that that's then these levels of 16s. And then they end up combining two 16s to make a 32. And they're doing the same thing for the last two, right? Because in this example, we end up having two groups of 32. And so again, I can just move the Cuisenaire rods to make that, this wonderful area model with these concrete manipulatives turning into this pictorial way and drawing a picture perhaps of the area model as well. So rather than leaving it here, which is an additive phase of reasoning, let's have an instructional move here. We might say back to them. So you're saying 8 times 8 is the same as 4 16s, and that's the same as 2 32s. And then put it back on the students and say, what do you notice? And what do you wonder? Right? It comes from the kids about, well, hang on, right? So here's this example of this double and halving. I have halved the number of groups, but I've doubled the amount in each group. I was able to continue doing that with this particular set of numbers. But here is how we can move from that additive phase of reasoning into multiplicative to the really big, powerful strategy of double and halving, because that double and halving strategy is not limited to basic facts. I can do it for larger numbers, decimals, and fractions. Crazy, crazy powerful.